Hi, I'm Mesa Salida, and we're here at Georgia Pacific's Foley Cellulose Mill.
Cellulose fibers naturally occur in all trees, and this place extracts it to use it in all sorts of things, like diapers, tires, and even hot dogs. This is a huge operation, one that produces 465,000 metric tons of product every year. Now, with that kind of output leaving this place, they've got to make sure it runs as efficiently as possible.
So that means finding potential problems and using science and engineering to solve them is a top priority.
We're visiting my friend Brian Tish. As a chemist here at Foley Cellulose, he puts science to work every day.
Hi, Brian.
Hey, Mesa, how's it going?
It's good. It's nice to be talking to a fellow chemist.
Yeah, it's great.
What type of chemistry do you do here at Georgia Pacific?
The chemistry that we do actually helps our engineers design solutions that improve the efficiency and safety of our mill.
To keep the cellulose production line on track, everything needs to work right. That means keeping these thousands of feet of pipe open and running so that millions of gallons of water can flow in and out of the mill each day.
So there must be lots of things for you to check on.
I'm getting ready to go do some rounds right now if you want to join me.
That sounds great. Let's do it.
Great, all right.
Water is essential to break down the wood into pulp. Once it's in pulp form, they can extract the cellulose. It's a very precise chemical process, so they have to constantly check and double check every part of the operation. Brian got word that one of the pipe's output is low, so we're going to investigate. Brian's on the case.
There's actually a pipe I want to check on over here.
Okay.
You see, look at all this buildup right here?
Yeah, like all of this stuff.
Yeah. I think that we should collect a sample of this and see what it is.
Okay.
If the buildup continues, it could clog the nozzles and jam the pumps and valves.
All right, I think we got enough.
All right, so let's take a look at that.
Yeah, sounds good.
So we found some buildup on a pipe out on the production line. So we're gonna run some tests to figure out just what it is. So what are we gonna do here, Brian?
Okay, well, we're gonna run a series of 4 different spot tests.
This hands-on investigation examines the chemical makeup of the buildup. Brian knows the chemicals used to extract cellulose might be in our sample, so he's going to run some spot tests on the usual suspects: calcium, iron, sulfate, and carbonate.
First thing we'll do is we're gonna take this and dump it into this beaker right here.
Which one of these tests do you think will be positive? Any change in color could reveal its chemical composition. The control sample remains constant during the entire experiment, so we can see when there are changes in our other samples.
First test is gonna be for carbonate. So we're gonna pour some acid onto the unknown here. Second test we're gonna test is for iron.
Remember, a good detective takes notes.
Take note of any changes you saw.
Okay.
We're gonna run a test for calcium.
So it's dark, cloudy, and kind of bluish, blackish, greenish.
We're gonna use nitric acid instead of sulfuric acid because sulfuric acid has sulfates in it.
Do you see any changes? This is some solid evidence about what's inside that buildup. Let's take this data to help us crack the case. So we've run our tests, and we found out that our unknown buildup had calcium carbonate and iron sulfate in it.
But what was causing it? And what's the best way to solve the problem? I think you brought me here, Brian, to figure that out. Where are we?
Yes, I have. This is a control room, and on these screens here is a program that we can control the whole process with.
The whole mill?
Yes, yeah, the whole mill.
Wow. So what are all these like tanks and?
Well, these are tanks, and then there are valves and pumps on here, and all these numbers actually have the different sensors that tell you how open or closed the valve is, and how the flow rates and things like that.
Oh, so the technology inside all those vats and tanks downstairs feeds into here.
That's right, yeah. And so we found the buildup right here, and what we can do is open this valve a little bit more and increase the flow rate of this pump right here, and that will eliminate the source of the buildup.
Let's rewind through our super sleuthing. We used our powers of observation to eyeball the buildup. Our investigation uncovered it's made of calcium carbonate and iron sulfate, and now we can put our data into action to make sure the pumps stay open and valves don't jam.
This is problem solving at its best. We found a potential problem and tackled it before it got out of hand. Remember, keep your eyes open. Science and technology are all around you. And until then, stay curious.